bisa mengulang-ulang apa yang disampaikan nanti oleh pembicara kita. Dan nanti acaranya juga akan kami berikan sertifikat eh, setiap peserta yang hadir yang mengisi absen nanti akan kami share. Dan juga nanti akan bila dibutuhkan ya kami akan memberikan juga modul presentasinya nanti kita akan diskusikan ya sesuai dengan kebutuhan Bapak Ibu ya. Oke Bapak Ibu semua eh, untuk menyingkat waktu ya saya akan buka acara ini dengan apa saya share sedikit ya. Oke Bapak Ibu semua. Em, saya sebagai official dari konsep pemain utama satu company yang berdiri sejak 2018 ya. Kami bergerak dalam bidang ICPM training and consulting, resource management, supplying, engineering, infrastructure, software solution, dan kami juga selaku authorized dari BNL Channel Partner. Alhamdulillah sejak berdirinya sampai saat ini kami telah memberikan cukup banyak kontribusi eh, bagi peningkatan kompetensi skill, tool bagi para praktisi engineering and construction, dan juga memberikan support engineering software solution pada beberapa perusahaan engineering and construction, baik lokal maupun multinasional. Dan sebagai Bentley Channel Partner, insya Allah kami siap ya mensupport ya servis semua kebutuhan virtuoso subscription software Bapak Ibu ya. Eh, Kenapa harus pakai virtuoso subscription? Karena kami pastikan software license ini jauh lebih murah ya, lebih efisien biayanya. Bapak Ibu tidak perlu membayar annual maintenance fee setiap tahun. Jadi bila Bapak tidak menggunakan lagi tidak bisa di stop, tidak usah diperpanjang tahun berikutnya, bisa dilanjutkan di tahun yang akan datang tanpa harus membayar annual fee setiap tahun ketika tidak dipakai. Dan sudah dipastikan ketika Bapak nanti memperpanjang apa menggunakan pada tahun berikutnya, Bapak Ibu akan mendapatkan the latest license software version dengan maksimal interface dan maksimum service support. Dan software yang Bapak Ibu nanti akan dapatkan ya itu sudah including dengan paket key trainingnya yang nanti disesuaikan dengan kebutuhan implementasi software Bapak Ibu semua. Ya. Jadi Bapak Ibu tidak usah khawatir ya. Apa saja kebutuhan software engineering Bapak, pastikan hubungi kami segera ya. Kami siap untuk mensupport ya secara maksimal semua pertanyaan dan kebutuhan Bapak Ibu. Nah, sebagai informasi ya eh, per tanggal 19 kemarin sudah lewat sebenarnya ya sampai besok ya tanggal 19 Mei kita ada spesial diskon ya untuk pengadaan pembelian software di bawah ini. Dan tak lupa saya ucapkan baik terima kasih kepada Bapak Ibu yang sudah hadir di sini, yang telah meluangkan waktunya, dan khususnya kepada Mr. Saurabh Saxena ya. Thank you so much, Mr. Saurabh Saxena. Ya, ya, you are willing to be a speaker of
You are
this webinar. Ya, thank you juga untuk Miss Cindy Chandra yang telah mensupport acara ini sehingga bisa terselenggara dengan baik. Acara ini bisa terselenggara tentu dengan dukungan dari Bentley System kepada kami sebagai Bentley Channel Partner. Mungkin itu saja yang bisa saya sampaikan, Bapak Ibu semua. Berikutnya kami serahkan kepada Ibu Cindy untuk melanjutkan sesi berikutnya. Terima kasih, selamat siang. Silakan Bu Cindy.
Terima kasih, Pak Aldrin.
Sama-sama Bu Cindy.
Oke.
Bentar ya, saya stop.
Selamat siang, Bapak dan Ibu sekalian.
Bentar ya.
Baik, Pak.
Silakan Bu Cindy.
Oke, baik. Thank you, Pak Aldrin. Screen-nya sudah terlihat ya, Pak ya?
Sudah jelas Bu Cindy.
Oke, thank you, Pak. Selamat siang, Pak Aldrin, Bapak Ibu sekalian. Terima kasih untuk sesi pada siang hari ini sudah menyempatkan waktu. Jadi pada siang hari ini kami dari Bentley Systems akan sharing mengenai bridge design dengan menggunakan BIM approach, yaitu dengan menggunakan open bridge. Salam kenal Bapak dan Ibu sekalian, saya Cindy Chandra, saya Product Sales Engineer untuk Product Structure dan juga Civil dari Bentley, khusus untuk Indonesia, dan bekerja sama dengan channel partner kami yaitu Pak Aldrin dari Construct. Dan juga untuk speakers kita pada siang hari ini adalah Saurabh. Jadi Saurabh adalah Product Success Manager dari Bentley Systems, khusus untuk Bridge Products. Sebelum kita masuk ke technical session, mungkin ada beberapa hal yang ingin saya sampaikan kepada Bapak Ibu sekalian. Jadi untuk topik pada siang hari ini kita akan ada 5 topik. Yang pertama adalah project delivery dengan menggunakan approach bridge information modeling. Kemudian yang kedua, interoperability antara model jembatan secara fisikal maupun analytical dengan open bridge. Yang ketiga adalah efficient design analysis. Yang keempat adalah project deliverables ataupun output dari yang bisa kita dapatkan dari software, baik secara drawing, quantity, dan juga geometry report. Dan yang terakhir adalah bagaimana open bridge ini bisa berintegrasi dengan roadway projects atau project jalan.
Around the world, engineers and architects, constructors and owner-operators are using Bentley's software solutions to design, build and operate the infrastructure that sustains our economy and our environment. Together, we are advancing infrastructure.
Jadi Bapak Ibu, kami adalah dari Bentley Systems, engineering software company. Dan Bentley punya banyak sekali product offerings yang bisa mengcover baik dari segi civil design, structure, kemudian buildings, tower design, bahkan sampai communication dan juga drainage design itu kami juga ada solusinya. Khusus pada siang hari ini kita akan lebih membahas mengenai civil solutions yaitu open bridge. Jadi seperti yang kita tahu ya Bapak Ibu, kalau project civil engineering itu ada banyak sekali. Seperti di gambar ini ada site development, ada jembatan, ada jalan, tunnel, dan lain sebagainya. Kemudian untuk project-project civil engineering tersebut, Bentley punya solutions. Yang pertama itu adalah open site, ini adalah untuk site design dan land development. Kemudian ada open bridge yang akan jadi topik utama pada siang hari ini. Kemudian ada road design atau desain untuk jalan. Kemudian ada rail design menggunakan open rail dan juga tunnel design dengan menggunakan open tunnel. Jadi seperti kalau kita lihat kembali civil engineering projects dengan solutions dari Bentley, kalau untuk land development kita ada open site, untuk road kita ada open roads, untuk bridge kita ada open bridge, untuk rail kita ada open rail, Untuk tunnel, kita ada open tunnel. Dan juga untuk visualization, misalnya untuk animasi project-project infrastruktur ya, Bapak Ibu, Bentley juga punya namanya Lumen RT. Dan juga untuk pemodelan data yang kita capture dengan menggunakan drone, itu kita ada namanya iTwin Capture. Dan untuk buildings, misalnya ada Start Pro. Kalau untuk drainage dan utilities, kita ada Open Flow, Open Utilities. Dan juga untuk geotech, kita ada Plaxis. Jadi untuk satu cycle civil engineering projects, Bentley punya solutions-nya. Dan Bapak Ibu, untuk semua software civil design tersebut, kita ada bundling yang bernama Civil Work Suite. Jadi dengan bundling Civil Work Suite ini, kalau Bapak Ibu punya project yang cakupannya lebih dari satu skop pekerjaan, misalnya ada desain jembatan, ada desain jalan, kemudian perlu juga untuk site design, itu bisa menggunakan package dari Civil Work Suite. Jadi nggak perlu beli license terpisah, beli satu bundling aja, maka Bapak Ibu nanti sudah bisa mengakses semua software ini. Kita akan masuk ke topik utama pada siang hari ini, yaitu Open Bridge. Kita akan undang Saurabh untuk join kita pada siang hari ini. Dan Bapak Ibu, mohon maaf, Saurabh hari ini agak kurang enak badan, jadi kalau ada suara batuk ketika beliau presentasi, kami mohon maaf. Hai Saurabh.
Hi Cindy, hello.
Hello. Yes, over to you. You can start to share your screen.
Okay, thank you Cindy, thanks a lot.
So,
Cindy, is my screen visible?
yes, visible. We can see now.
Just a minute. Think there is some issue. Cindy, can you please let me know my screen is visible in presentation mode or not?
It's in slide mode, so we can see your slide on the left,
Oh, it's not,
not
getting
in the
changed.
slideshow.
Let me share it once again.
Okay.
Now is it visible?
Yes, now visible. Okay. All good now.
Okay. Again, something happened.
Okay.
Just give me a minute. There's some problem.
No issue.
Now I think everything is okay.
Mm.
Okay. So thank you, Cindy. Thanks a lot. First of all, I really appreciate that all the participants took out their precious time to attend this webinar today. Before starting, first of all, I would like to introduce myself. My name is Saurabh Saxena. I have been working as a bridge design engineer for last over 8 years. And right now, that is currently I am working as a senior product success manager in Bentley Systems and looking after OpenBridge designer solutions. So before starting that topic that advanced bridge design workflow, advanced as we are trying to automate the process. We are trying to automate the process. So I am here to present the comprehensive civil engineering tools for bridge designers. So to understand first of all that how the automated process will evolve, let's start with a look at the traditional construction process which you all are aware of. That comprises of planning, then survey, then design, then layout, execution, inspection, and maintenance. But as you all aware that this is a linear process and there are different and many stakeholders are present across the different project life cycle. That is, I mean to say that is for planning, it may be a different stakeholder. For design, it may be a different stakeholder. And for maintenance, there may be a different stakeholder. So this is a linear process and it can only be improved to a point. But it is clearly a time to now rely on technology to connect all the players seamlessly on the project, keep up with the expected changes, and visualize virtually for early identification of problems before they really are the problems. So for that, what we need digital components and digital workflows for the seamless flow of data between the different stakeholders across the project life cycle. And digital construction requires integrated solutions. So what do we want? We for integrated solutions, we want 3D modeling for design in a collaborative environment, and then extending that same 3D model and collaboration into the construction phase. I mean to say, at the concept stage, we have created a 3D model, and that same 3D model we have extended for the construction phase. And then comes the e-construction. This indicates a move towards digital and electronic processes in construction, likely for efficiency and data management. Then comes the manage assets. It's a focus on the long-term management and maintenance of constructed assets. At the top, vision represents the overarching goals and future direction, likely encompassing innovation and sustainability in the built environment. So, what do we achieve with that? I mean, with 3D BIM model at the concept stage or visualization state, uh, uh, serve the purpose of data, information, and shareable knowledge between the different people, application, and different discipline, along with the time across the project life cycle seamlessly. You can see that in current practice, there is loss of data which results in lot of rework. But with the connected data environment, the value of this data information and knowledge sharing increases significantly. However, the the accuracy and details of 3D model, I am not saying that these can be achieved at the visualization or concept stage, but this can be improved towards fabrication stage. As you can see on this slide, at the lowest level of detail, 3D models are used for basic visualization and conceptual design. And as the model develops, they are used for conflict resolution, identifying and resolving clashes between structural, mechanical, and plumbing or electrical. And the highest level of detail you can see at the top, that is detailing and fabrication, where the models contain precise information for manufacturing and construction. And if you integrate the time as a dimension, then it becomes a 4D model which can be used for construction management as well. So by now you would have realized that with Open Bridge Modeler, we are trying to achieve or we are achieving a connected data environment that is seamless workflow irrespective of the discipline and location of the project. people throughout the project life cycle of design, build, and operation phases. Now, before diving into the OpenBridge designer integrated workflow, let's have a look on the current disconnected bridge workflow, which you might agree that we are currently, most of the companies are currently following. So what we are doing now currently, or mostly the companies are doing, engineers are doing analytical model and they are designing. Then after designing, whatever the results they are getting, whatever the sections they are getting, they manually transfer the data to drafters. So then drafters produce 2D plans, production, then quantities and detailing. And then that data, after compilation with the engineers and drafters, manually we transfer for the construction and asset management. But you all have experienced in your tenure as an structural engineer or bridge engineer that this result in a lot of loss of data loss, lot of data loss, and as well as lot of rework. And the most critical condition arises when one of the engineer or drafter leaves the company, then it is very difficult to gather that correct data. Now coming to the OpenBridge Designer integrated workflow. So what OpenBridge Designer is? OpenBridge Designer is a unique application that combines modeling, analysis, and design into one comprehensive bridge product, as it creates a true BIM model, that is 3D physical model of your bridge from the beginning of your project. The application utilizes the modeling capabilities of OpenBridge Modeler and analysis. I repeat, the application utilizes the modeling capabilities of OpenBridge Modeler. There you cannot design and analyze. And analysis and design features of that means you can design and analyze after extracting that physical model to either leap bridge or RM bridge. That is leap bridge steel, leap bridge concrete, or RM bridge. So you can see that in this slide that we can do the 3D physical modeling. The same model can be extracted for analysis and design, and then same model can be updated and the OpenBridge modeler for design documentation and geometry reports, 3D models, and annotated drawing. You can also use that same model in pro structures for detailing the reinforcement, and then same model can be transferred for construction and management activities. So this is the general GUI of OpenBridge Designer. The moment you will launch or open the OpenBridge Designer, you will be having the option of either selecting BIM workflow or standalone workflow. So in BIM workflow, what happens? You can only create a 3D model, but in standalone workflow, you can even take that model for analysis and design. So in standalone workflow, you can create several groups, and after creating the group, you can create your 3D model in modeling, that is OpenBridge Modeler, and then you can take that same model for analysis by by various tools available in OpenBridge Designer, and these are interoperable. I mean, these are the movement can be to and fro. You can take your model from OpenBridge Modeler to analysis tools, and you can update the analysis and design model to OBM back. So this is the general flow workflow of OpenBridge Designer. First, you have created a model on OpenBridge Modeler. Then you have transferred, if it is a steel structure, then you can transfer the same model for analysis and design to leap bridge steel, like this. Or if it is a concrete structure, PSC or RCC structure, you can transfer your model to leap bridge concrete. There you can do analysis and design. And if it is a complex structures involving so many construction stages or something like that, I mean to say like segmental bridges or something like that, then you can transfer your model to RM bridge, and there you can design the most difficult bridges what you can imagine. So this video is depiction of creating a PSC girder bridge on OpenBridge modeler. So first of all, what you need, these three lines which you are able to see on the screen is actually the alignment and profile. So for creating a bridge model on OpenBridge modeler, you need to reference the alignment and profile from roads department. After that, you need to, in bridge setup, as you can see here, in bridge setup, you need to add the bridge. Just select an alignment on which you want to model your bridge. So I have selected the alignment. You can also reference your terrain model here in the open bridge modeler. So all the roadway data you can easily reference here in open bridge modeler. So see, I have referenced the terrain data as well. So I have referenced my alignment, I have referenced my terrain data, and I I just define my bridge on alignment, rightmost alignment. After that, you need to place the support lines. What are support lines? Support lines are basically the location of your abutments and piers. So you need to define, after defining the bridge, that we have defined that pre-stressed girder bridge we are going to model. After that, we are defining the support lines. So here you need to specify skew angle, length, span length, start station, end station. At this point of time you need not to worry even if there is any change in the spans in between. Just click on this. See, this pop-up window will open. Here you can change the name like A1, P1, P2. You can change the span length, so automatically your bridge will set up to the desired location. Okay, so these we have created the support lines. 7-span bridge. Now, what you need to do, you need to place the superstructure. So in superstructure, first select the place deck. There are various templates available in the library. You can select those templates from the library. And if you want to change anything in that template, then you can go to the utilities library. There already you can see some predefined variable, like here you can see the P1, P2, P4, P5 are the points which are defined with respect to variable, which are defined as a variable with respect to the origin point, that is P0. So if you want to change the right half deck width, left half deck width, or slope, you can change it easily from this table. So here it is as defined, or in addition to this, if you want to define that your deck type is not in the library, you can create your own template as well. There is no restrictions for that. You can create your own template and define. So if it is a simple bridge, then you have to select each and every support line for placing the simple deck. And if it is a continuous, then just select the first support line and last support line, then your deck will be placed. As you can see in 3D view, there I have opened two views, one on the left side and one on the right side. So you can easily place your deck. Now you need to select what after deck, you need to select your beam layout. So the moment you will select the support lines, this window will pop up. How many number of beams you want to place? What is the edge distance you want to keep on both edges? You can define. And even if you want to change the beams in between, I mean to say that right beam you want to keep something else, left something else, intermediate something else, that all freedom you have. So just select the beam layout, then you can place the beams as well, like this. Just selecting the beam layout and accept it, then you can select the beam as well. Now here easily in this pop-up window, you can select the templates or you can change the template as well. So now beam is placed. You can see in the 3D view, you can change your view as well. I mean, From wireframe, you can change this to illustration view. There you can see the solid representation of the various components of the bridges. So here you can see what we have modeled till now. Now after that, after placing the superstructure, DAC and beam already we have placed. Now comes the part of placing the substructure. So go into the substructure, select place abutment, select the template. Again, I'm not, if I forgot to repeat it again, template, there are various defined templates in the library. And if it is not as per the requirement, then you can create your own template as well. That is a no issue. So this template name you can select from this pop-up window, and horizontal offset, if it is there, confirm back wall with deck top, elevation constraint, if any you want to give. If you have referenced your terrain model, then you can give elevation constraint and orientation, whether you want to place your abutment at the start or at the end. And cap length adjustment, you just select all these parameters and simply click on the support line where you want to place your abutment. Then your abutment will be easily placed like this. So same again at the start of the, you need to change this orientation at the start. If you want to place your abutment at the start location, just select the support line again. Your next abutment will be placed. Now next comes the placing of piers. So again, you need to go to the place pier in the substructure like this. Place pier, you can select the various templates available in the library from multi-column. Piers, you can select these and just simply click on select. And after selecting your template, you just need to define if there is any horizontal offset, cap length adjustment, or elevation constraint, and then just click all the support line where you want to place your piers. So you will be able to place all the piers in one go if it is of same dimensions. So now in the 3D view, like this, we have referenced the terrain model. So I'm keeping my all the footings from the ground at a level of 4 meters below the ground. That is, top of the footing is 4 meters below the ground. This now comes the part of placing bearing. We have placed the superstructure, we have placed the substructure, and now it comes the part of place bearing. So here you can select the, in substructure only, you can select the place bearing. Bearing type you can select from cube, sail, or whatever it is. Then you need, if it is any grout pad or bearing seat, you need to select it, and you need to specify the dimensions like this, and the seat orientation, and back offset, and ahead offset, means from the center line of support where your ahead bearing will be, and where will be your back bearing. So just select the all the support lines, then your bearings will be placed in a very swift manner. You can see on right side view, your bearings are placed with the bearing seats. Now comes the part of placing the crash barrier. So in auxiliary, you can select the crash barrier templates if it is there. If it is not there, again, I would say you can define the template as per your requirement and place it on your bridge structure. So just you need to select the reference point for placing barrier. Reference point will be either your right edge of the deck or left edge of the deck. So you need to select that point from the select guideline from list. So for placing the right barrier, you need to select the P1, and for placing the left barrier, you need to select the P5. As you can see here, P5 is selected, then left barrier will be placed. On the right window, the left barrier is placed. Similarly, you can place your right barrier in your bridge model, and then your bridge model is completed. So not only you can model your bridge with Open Bridge Modeler, you can also visualize your bridge in reality context. In addition to that, not only one bridge, different complex construction stage can be handled through OBM by defining build order and by defining as many number of bridges as you want in Open Bridge Modeler. So from starting to end, we deal with only one model across the various life cycle of the project. Now coming to the types of bridges in Open Bridge Designer, we can do pre-tensioned concrete girder slab bridges, steel girder concrete slab bridges, segmental bridges, and cast in place concrete boxes and slabs. So as you can see in this slide, you have various tool sets, superstructure tool sets for modeling the plate girder bridges and RCC girder bridges or PSC girder bridges or PSC box girder bridges from using the OBD native geometry tools. And as you have already seen in the previous small clip of Open Bridge Modeler, that you have various substructure modeling tools as well for abutments like stem wall, pile cap, and user defined. And for piers, wall piers, multi-column piers, hammerhead piers, pile bands. And if you want to define anything, then you can also define as per your requirement. Now, one thing I want to cover in this, if you are creating your own template, there is a very special capability of OBM is while defining your own template, you need not to define the exact dimensions at that point of time. I mean, what it means that at later stage, you can change the dimensions of your defined template as well. By what? You can define the variables. As you can see in this clip, we have defined variable for each and everything: cap left length, cap right length, cap height, cap depth. So if at the later use in my project I want to change my dimension, I can easily change these dimensions in my template. Column height, column width, whatever, piles, number of piles, the geometry of pile, whether you want to make it circular or rectangular, you can change each and everything very easily if you have defined the variables while creating a template for your purpose. So each and everything you can change very easily with this method. I'll move ahead. Now coming to the first analysis tool, which is provided in the Open Bridge Designer, is Leap Bridge Concrete. So Leap Bridge Concrete supports multiple bridge configuration, including simple and continuous span, straight and curved bridges of small to medium span. It is interoperable with other Bentley softwares I have already shown. And as of now, LeapBridge Concrete supports US ASTO codes, Canada CHPDC, and Indian IRC codes. But for preliminary analysis, you can do with LeapBridge Concrete very easily. In addition to the design and analysis, LeapBridge Concrete also include tools to quickly develop load rating models, compute inventory and operating load rating in conjunction with the design specification checking by applying the requirements of Manual of Bridge Evaluation. So this is again a small clip showing the interoperability of OBM and LeapBridge Concrete. See, I have already defined a bridge model in OBM, that is Open Bridge Modeler. And then under utilities, I just clicked on LeapBridge Concrete and send this model to LeapBridge Concrete. Then you will see the model transfer report. It will show what will be the limitations of transfer and how each and everything will be transferred to LeapBridge Concrete. Then automatically LeapBridge Concrete will launch, And in this project, you need to select the design code and analysis option. As you can see at the top, there is geometry, superstructure, substructure, reports, and drawings. So even after extracting your model from OBM, if you want to change anything for design purpose, you can easily modify the dimensions as per your requirement. So going to the superstructure, this is the model which we have transferred, which we have extracted from the OBM. Now, going into the precast pre-stressed girder, I have the options to select the design code here as well. And I can go into the geometry, and if I want to change anything there, then I can change. If not, then I can go to the materials and define the materials. Even for concrete and pre-stressing steel, this is very interactive load input wizard. And then you can go to the analysis, and if you want to change any analysis factor or design parameters, you can do that easily, or else you can directly run analysis if you don't want to change anything. So your analysis is run for various combinations, and this is very good tool for preliminary analysis. That for PSC girders, you can go to the auto design feature of this software. Then you will get to know a preliminary design requirement. And see, I have auto designed it, and in certain criteria it is not getting passed. So what is the advantage of interoperability in OpenBridge Designer? You will understand here that what I will do in LeapBridge concrete only, I'll change my depth of girder. I'll change the depth of girder, and then again check the design. See, I have changed my beam template for one span only. For only one span, I have changed my beam template. Then again it will ask for material loads and analysis. Then I run the analysis. Then go to the auto design feature. Now it is passing everywhere. If I want to keep that strand for all other beams, I can easily copy that strand pattern for all other beams as well. So now you can see here, my beam is updated in the first span. You can see here, my beam is updated here. And then this model can easily be updated to OBM model as well. You just need to go into the tools, and then OBM sync, then send to OBM. Then that model in OBM will automatically updated as per the design requirements. You just need to update that model. We have transferred this model to OBM again. Then go to OBM and update from LeapBridge Concrete. See, it will ask whether you have to accept all the changes or not. I clicked on accept all the changes. Then in 3D view, you can see my first span beam depth is updated here. It means that whatever change you will made in LeapBridge Concrete or any analysis tool, it can be easily referenced to OBM again. So there is no manual transfer of data. automatically it will happen. Now coming to the second analysis tool, this is very similar to the Lee Bridge concrete. The only difference, it is used for the simple and continuous spans of steel girder bridges, that is plate girders or tub girders, and load rating system of steel bridges, as you can see in this slide. Leaf bridge steel has two analysis options. First is line girder and second is grillage. These pictures on this slide shows some analysis results for moment and camber. So you can easily check the analysis results graphically for different load cases, and you can also see the camber profile for the various combinations. For 3D finite element analysis, you can check the deflection diagram and moment diagram with color coding graphically to realize where your engineering attention is required. In addition to the generation of camber diagrams, it can easily export it to DGN file as well. After analysis and design, you can create reports from LBS also, that is leaf bridge steel also, for section properties, section limits, factored forces, factored stresses, and for various service limit state and strength limit state and fatigue state at various locations. I mean, at the nodal points or at the intermediate locations, you can check all that in reports with under and over design, whether it is, I mean, whether it the section has passed or not. In addition to that, the reports has references to LRFD articles and equations as well, and you will have the summary reports finally, whether the section is under design or over design, as you can see in this snips. Now coming to the most versatile tool of OpenBridge Designer, that is RM Bridge. So RM Bridge, you can design from simple to most complex structure in RM Bridge. All the reinforced and pre-stressed concrete structures can be designed in RM Bridge, analyze in addition to design, and you can do the analysis as well. So that is understood. Steel, concrete, and composite bridges, cable stayed bridges, suspension bridges, arch, truss, whatever it may be, you can analyze and design in using RM Bridge, or whatever is the erection method, that is by span, advanced shoring, incremental launching, balanced cantilever, precast, segmental. So RM Bridge is basically a differentiator because of its unique capabilities. It has 40 years of engineering experience. You can do all types of analysis from static to dynamic, linear to non-linear, grillage to FEM. It supports all the construction method, whether it is segmental, incremental launching, staged construction, whatever it may be, you can simulate with using RM Bridge. RM Bridge, in addition to that, RM Bridge is perhaps the only software that offers a wind tunnel analysis on desktop, and it supports over 20 international design codes. So this is a snip of finite element analysis done on RM Bridge. This is moment results for self-weight load case. You can see easily, you can identify where it is hogging, where it is sagging, to arrive at the better engineering judgment, where engineering attention is required, as the color coding is provided is with the help of color coding coming on the uh, analysis results. So this is again a small video showing the interoperability of OBM, that is modeling a segmental bridge in OBM. That it is a balanced cantilever type of balanced cantilever bridge, and then I'll transfer the same model to the analysis, one of the analysis tools, that is RM Bridge. So again, I have already referenced some alignments. Then I'm adding a bridge on one of the alignment here. Segmental bridge I have added, then multi lines I am placing, and again, no need to worry, I'll change my span length here, as I already mentioned. Here I have changed my span length, whatever I wish as per the project requirement. Then go to the placement of decks. Then you can select the template. Here we will place the parametric segmental box. If you want to change anything, go into the library utilities library. You can change the dimensions, as already some variables are predefined. As you can see, I am checking with the box depth, everything. And then just go into the segmental, place segmental. The first I have selected the segments near to abutment. What they will be placed. So just 2 segments near the abutment I will be placing. And pier segment length you need to define back ahead, means the segment at the abutment or pier location, which is cast in situ mostly. So I'll define those and then I'll place my segments other than the closure segments. I repeat, other than the closure segments, I'll place everything in this model. So I have selected the pier. I placed 14 and 14 segments on the right and left side. As you can see, 14 segments of 3.3 meters and 14 segments of 3.38 dimensions. And this back and ahead segment is 2.4. 2.4 is the segments above the pier. Similarly, I will place all my segments one by one, except the closure segments. I need to place my closure segments explicitly, because closure segments are cast in situ, as you may be aware of that. So now after defining all the segment, see here, this space is cast in situ. So I need to place the closure segment here. I will select the place close, then I'll place the closure segment. One more thing, then right now I have followed a constant depth of the box girder throughout my bridge. But on going to constraints, here you can see, here I have gone to constraints to define any variation in my dimensions of box girder. So simply I need to select what variation I want to do and then define the variation. Then you will see now I have defined the variation. See here, your box girder depth is varying with the span length. Now there comes the placement of substructure. So you need to place the substructure, that is pier and abutment. In the same way, just select the place abutment and select the place pier, select the required templates. If you have already referenced your terrain model, then you can place your footing as per the terrain model, at what depth you want to place your footings. So now you need to place the abutment. So you, from pile cap or stem wall, you can select which type of abutment you want to place. Just select the abutment, go to select and select the support line to place the abutment. So abutments also placed. Now the last part is to place the bearing. Just select the template for the bearing, define the offsets for the bearing and place it by selecting the support lines. And if it has any grout pads or beam seat, you need to define the dimensions and select on the grout pad and beam seats. After defining all this in this pop-up, you need to select the support lines and just place the bearings. For placing the bearings, this transverse offsets also you need to define. from center line at what distance you want to place your bearing in addition to the ahead and back offset. Similarly, you can place other bearings as well. So once you are done with in the same way, you can define the crash barrier as I have already shown in previous snips. So once you are done with your model, move ahead little bit. This in auxiliary, you can place wing wall, lightings, whatever you wish, you can place it here. And here, see, after completing your model, just select the RM, send the data, send the model to RM. Then this pop-up window will come. I'll pause here. The moment you will select the send model to RM, this pop-up window will come. So before the model is extracted to RM, the software will ask you to define these things. Whether, I mean, if the support conditions you need to define here. For piles also, you can define the spring constants, whatever you want to keep. The supports, whether or by default it is as per your desired, or you want to change it, you can change everything here. And materials also you can define, and the same will be transferred to RM. So here you can modify your support conditions easily, and materials. After defining each and everything, you can click on connect to RM, then the physical model will be extracted for analysis and design model by RM Bridge. See, that physical model is converted to analytical model for analysis and design by RM Bridge. Here comes your analytical model. So in modeler, if you want to modify anything, like if you want to modify cross section, if you want to change any variation in your geometry, if you want to change anything here, you can easily change. And in addition to that, this, if you can see at the bottom, there is reference set. The reference set is basically a collective of cross section reference point and lines for describing spatial cross section properties or geometric entities. Like to predefine some points where you want to calculate the stresses. So here you can see you have the view options. You can change your view options to draw cross section, draw element bodies. Then you can see, you will be able to see the complete 3D view of your segmental bridge. After that, you need to define in analyzer, you extract your model to analyzer. There you can define the loads. So I have defined in load case definition. In the upper table, I have defined one self weight. And in the lower table, I will apply the loads post selecting on which elements I want to apply. So I have selected modular, that is on each and every element I want to apply my self weight. So you can see in this window, you can easily cross check whether your load application is correct or not. Now you have to schedule the actions. I mean, you can schedule your construction stages as per your requirement, and you can activate at different stages. However, I am not considering in this snip creep and shrinkage, so I have kept the time as 0 for everything, but I can define for those as well. So in schedule actions, you need to define the calculation of that load at what stage you want to define as per your requirement. So I have defined the calculation of my by cal section in final stage only, because I am considering only self weight. So you can analyze the structure again, and after analysis, you can check the results, that is moment results or deflection of the cantilever, balanced cantilever bridge. So you just need to go on the result view options, select which load case you want to look after and which type of result you want to see, whether it's deflection or moment diagram or shear diagram, whatever you want to see, you can select from here and apply and see. You can see the results with color coding graphically. So RM Bridge, you can define everything, all construction stages, everything you can handle it here in RM Bridge. And all types of result presentation, as I have already shown, that is stresses, forces, displacement, whatever it may be, you can view the results easily graphically. In RM Bridge, the load definition of live load is very easy and very interactive. I'll again play a small video. So you need to go into the load definitions, load management and traffic lanes you need to define for calculation of influence lines. So I have created one lane in the upper table and see how interactively and graphically you can select the elements on which you want to place your lane. So I have selected my element and then EY and EZ you can define, that is eccentricity easily, where you want to place your lane. Here the lane positions come, then go to load trains. You can select the standard load train and create live load stages as per the different codes already mentioned, already is there in the library. So you can select. By doing this, you cannot, it is not mandatory to use this standard load train. You can define your loads as well. Here you can view your loads as well for live load as per the standard load trains. But by selecting from standard load, the advantage is that in schedule actions, you need not to define the various steps. Automatically, all the steps will be created for calculation of influence lines and live load superposition. You can define tendons very easily and interactively in OpenBridge Designer. You can design that in modeler part or analyzer part. You have both options with respect to the cross section point, element, or nodes, whatever it may be. So I have defined few tendons here. You can see graphically whether your input is correct or not. It is easy to get the feedback. And the advantage of defining tendons in modeler is that if you insert any segmentation, new segmentation, then tendon profile will automatically get updated, because it is based on stationing, not segmentation. You can see all the tendons is defined here. And I am inserting one segment point here. So automatically the tendon profile will get updated. So this is the tendon definition. You can easily define using RM Bridge. In addition to that, variable deck width along the bridge can be easily defined. The deck with variable super elevation can be defined. Now coming to the different aspect of RM Bridge, that is RM Bridge can also handle the rolling stock analysis, that is sometimes it is known as RSI analysis. So for rail bridges, RM Bridge provides a unique calculation engine that will simplify the given structure and apply to its several trains at several speed. This process in several phases where the bridge structure becomes more complex will reduce the scope of trains and speeds. So at the end, the bridge in its complex structure can be analyzed using the worst train at the worst speed to get the maximum response expected of the bridge. You might be aware of this advanced function is largely used for high-speed trains across Europe. Now comes the most interesting part of bridge engineers is seismic design. You might be thinking Saurabh should tell first whether what type of seismic analysis can handle RM Bridge. So I'm happy to let you know that RM Bridge offers can handle all types of seismic analysis. you are aware of, there are two different types of seismic analysis. One is force based and another is displacement based. Currently, mostly the force-based analysis is used. It may be equivalent static analysis or response spectrum analysis. And for complex structures, we may use the nonlinear time history analysis as well, if it is a complex structure and important and in poor ground condition. In addition to all these, the displacement-based design for seismic is also supported by RM Bridge, that is non-linear static pushover analysis can also be done with RM Bridge. RM Bridge offers several dampers and isolators as well. Three damper types are offered, which are mentioned here: viscous damper, Kevin Boyd damper, and Maxwell damper. And there are three types of isolators which are offered: lead rubber bearing, bilinear static, and friction pendulum. Now I'll show some of the case studies in which RM Bridge is involved. One is extra dose bridge Pragati Maidan. In this project, RM Bridge was used to design unique bridge involving complex geometries. This is Vandra Worli Sea Link Bridge in Mumbai. RM Bridge was used to design the unique bridge involving complex geometries. This is one of the segmental bridge in which RM Bridge was used. And in high-speed rail France, Arcades used the RM Bridge for design and analysis. Now coming back to the final deliverables which bridge engineers need to submit after all the design, analysis, and modeling is reports. Here comes the most important part, not that hectic, but most important part. So after doing all the analysis and design from OBM, you can create the various quantities report, that is concrete cost estimate. If you define the unit price for the various materials, you can create the cost estimate as well. Various geometry reports, deck elevation reports, beam seat elevation, pier elevation, whatever it may be, you can create with a single click. So this is a small snip. I have extracted the model again in OBM after analysis and design, and then I have gone to the analysis and reporting and created some geometry reports just by a few clicks. As you can see here, this is the deck elevation report showing the station elevation offset. This is beam elevation report, and you can select from in bearing seat elevation report as well. This is same analysis and reporting. You can create the quantities and cost estimate report. Just you need to select the bridge and submit. And see, you will have the superstructure, substructure quantities along with the cost. So with few simple clicks, you can create the quantities and cost estimates. Now comes the most important part and most amazing part of OpenBridge Modeler is managing design changes in OpenBridge Designer. Here, as you can see, I want to move my bridge a bit ahead. So just I have to click the point or station from where I want to move ahead and select by how much length I want to move ahead. With few simple clicks, in few minutes, I can change the location of my bridge easily. Here, if you want to change your bridge alignment, I mean, currently the bridge is on the leftmost alignment. Now I want to shift my bridge to this sorry, right curved alignment. So just go to the alignment in bridge setup. Just go to the alignment in bridge setup like this and select the new alignment on which you want to place your bridge now. So automatically within few seconds, you will get your bridge on the updated alignment. Now, if you want to update your bridge elements, you can see in this video easily. You just need to click on the elements like here in this peer dimensions. I want to update. So this pop-up icon will occur. Just after that, I need to select the substructure template, and here I'll see the cap, columns, strut, footings, whatever dimensions I want to change. I can simply change it here. I can change the geometry as well. I want to make my column now circular. I can change it. I want to make the second column as well circular. I change the footing from isolated to rectangular combined. I want to change my piles as well. That is its geometry from rectangular to circular. And I want to change the pattern of the piles as well. So I can just click on the pattern layout. If I want to make it manual, that also I can do manually. I can enter the coordinates of the piles, or else I can update here as well. That is what top margin I want to keep, what bottom margin I want to keep, number of rows, number of columns, whatever it is. So just in few minutes I can change, or few seconds I would say, I can change these things. You can see I have changed my one important thing I want to tell you, that whether we are changing this, there are two options. See, add to library and add to, or okay. If you click on add to library, then the template in the library will permanently get updated. And if you click on OK, for this purpose only, the dimensions will be changed. Elevation constraints, if you want to, if there are any hindrances at the site and contractor is asking you to move your footing upward or downwards due to some utilities, you can do easily with OpenBridge Modeler and pass on the same model to different stakeholders. This video shows that you can do the conflict resolution, or I am here showing the clearance verification. I am having one bridge above another bridge. So I want to check whether there is minimum clearance guidelines is satisfying or not between the bottom of the pier cap of upper bridge to the top deck top of the lower bridge. So you just need to go into the utilities. Here you can see I want to check the clearance here. You just need to go into the utilities and then clash detection. So here you will ask to create one new job, then you have to create a new job, then you have to select the two sets in which you want to check the clash or you want to check the clearance. So I have selected set A as OBM caps and set B as deck. Set B as deck. And now I'll define the clearance. So reports will a report will generate whether that clearance is there or not. Then I can toggle with few surroundings, and I can also isolate that part in which my clearance is not satisfied. So easily you can resolve this clearance issues as well. Now this is one of the most important part who are involved in mostly the that is tender activity, pre-tendering work, evaluation or alternative. So I feel by now you would have realized that this product is gonna save a lot of time and complete project with more accuracy. And in addition to that, it is very handy if you are evaluating two alternatives for a tendering purpose. So you just need to create two models on the OBM and define the materials and define the unit properties. Then easily you will get the quantity and cost report for superstructure and substructure. I think in very swift manner. Now comes the plan production part. Not only analysis, design, managing design changes, all that you can quantity reports. You can also produce the section, plan, elevation, 2D drawings from the 3D models using OpenBridge Modeler. So this is a small video showing the drawing generation. I think there is some issue in this, so I'll skip this for now. It's not playing. Coming to the next part, OpenBridge modeler models are can easily be integrated with pro structures as well. You can easily you can easily model the rebars with pro structures, and eventually you can create the bar bending schedules as well. So with OpenBridge designers, lastly, I would say that you can really deliver a 3D digital delivery for bridges, because all the Bentley software, that is OpenBridge Designer, Pro Structure, Synchro, which are required at different phases of project life cycle, saves the file in DGN file format, and you can share with different stakeholders and different agencies involved. So for now, thank you from my side. Thanks for listening to me. Thanks a lot. Open for Q&A.
Thank you, Saurabh.
Thank you, Cindy. Thanks a
Thank
lot.
you so much for sharing with us. Oke. Bapak Ibu mungkin ada pertanyaan atau ada yang ingin ditanyakan? Mau dalam bahasa Indonesia boleh. Nanti kita bisa jawab, kita bisa bantu.
Silakan Bapak Ibu, nggak usah malu-malu, langsung tanyakan saja apa yang mengganjal.
Jangan malu-malu ya, Pak.
Iya, iya.
Mungkin sambil menunggu pertanyaan, saya share 2 slide ya, Pak ya, sebentar.
Silakan, silakan.
Oke. Jadi Bapak Ibu sambil menunggu pertanyaan yang masuk, mungkin saya mau sharing kembali, tadi sudah di-mention oleh Pak Aldrin ya Pak ya. Kalau kita ada license tipenya yang subscription per tahun, namanya Virtuoso atau Virtuosity. Jadi kalau dengan license Virtuosity itu, Bapak Ibu tidak perlu khawatir dengan yang namanya biaya maintenance tahunan, karena itu tipe license-nya adalah subscription per tahun. Dan Bapak Ibu tidak hanya mendapatkan license-nya aja ya, tapi juga mendapatkan expert services yang kita beri nama key. Nah, key ini nanti bisa ditukar dengan training. Nah, trainingnya itu ada 3 pilihan Bapak Ibu. Yang pertama itu adalah tailor-made training program, artinya Bapak Ibu bisa request kalau misalnya ada topik-topik khusus yang mau dijadikan bahan training. Kemudian ada on-demand courses. Kalau on-demand courses ini adalah video recording training yang sudah tersedia di website Virtuosity, bisa langsung ditukarkan. Kemudian yang terakhir adalah mentoring services. Jadi kalau misalnya Bapak Ibu punya isu ataupun ingin diskusi dengan expert dari Bentley terkait proyek yang sedang berjalan, nah itu boleh menggunakan key dari Virtuosity. Nah, nanti untuk semua sesinya ini akan dilaksanakan by online ya, Bapak Ibu.
Oh, Silakan aja di chat aja, via chat juga bisa ya Bu Cindy ya.
Atau mau open mic
Bacakan nanti
langsung juga
guide-nya
boleh,
atau
Bapak Ibu.
langsung
Kalau
juga bisa.
mau open mic langsung juga bisa.
Jadi software ini bisa terintegrasi ya Bu Cindy ya dengan software lainnya ya.
Betul Pak,
Dengan
sudah bisa
satu
terintegrasi.
integrasi ya.
Oke, kita ada pertanyaan nih Pak dari Pak Dedi. Hi Saurabh, we got our first question.
Yes, Cindy.
Okay, so the question is, can OpenBridge generate the quantity?
Yes. I already mentioned in my presentation that you can generate all the quantities in OpenBridge Modeler. But the requirement is you need to define the material as well. So you will get all the quantities for superstructure and substructure.
Okay, thank you. Jadi Bapak Ibu dan juga Pak Denny ya, kuantitinya itu sudah bisa di-generate ya Pak, seperti tadi sudah di-show oleh Saurabh. Poin pentingnya adalah yang penting kita sudah input untuk materialnya. Jadi dengan input data material, maka baru bisa di-generate kuantitinya oleh software OpenBridge. Ada pertanyaan lain lagi mungkin Bapak Ibu? Nggak
Cindy,
apa-apa.
check
Yes.
the chat as well. I think there are few questions there. I don't explain it to me if there is.
Thank you, Sarah, for the reminder. So we got one question, the one that I already asked you.
Okay, no issues, no problem.
Or maybe Saurabh, can you please share with participants from your presentation, we can see that our OpenBridge also have a Leap Bridge software. So
Yes.
in case they want to know what is the differentiator between the Leap Bridge and OpenBridge, which one they should use if they got a simple bridge project?
Okay, so Open Bridge Designer, as I already showed in my presentation, Open Bridge Designer is a comprehensive tool comprising of Open Bridge Modeler and analysis tools, LeapBridge and RMBridge. So if you are having a simple bridge, not having any critical construction stages, then you can use LeapBridge for simple analysis. And if the structure is complex and it involves so many construction stages and it is means analysis and design is governed by construction stages, then you need to go for the RM bridge.
Okay. So it depends on the project, whether it's a small or big project, our OpenBridge can accommodate that. Okay.
Not actually on the small or big project. It depends on the type of structure, whether the
Type of the
structure
bridge.
is simple or structure is complex.
Correct.
Because in this meeting, I think all the bridge engineers understand nowadays different construction techniques are used. So those construction techniques results in a hell lot of variation in analysis and design of the structures.
Okay. Okay, Sarah, noted. Bapak Ibu mungkin ada pertanyaan
Thank
lagi?
you.
Thank you.
Ini ada pertanyaan ya.
Sepertinya belum ada pertanyaan
Belum ada
lagi,
yang
Pak Aldrin. Mungkin nanti menyusul ya,
Ya,
atau
ya,
mungkin
ya.
setelah webinar.
Ya, oke. Apalagi Bu, sini mau sampaikan mungkin.
Cukup Pak dari
Cukup
kami.
ya dari Pak Mr. Suarab. Ya, sudah cukup banyak ya. Nanti kita bisa share videonya ya Bu Cindy ya.
Iya, boleh Pak.
Share videonya, nanti Bapak Ibu bisa akses linknya dari kami. Dan nanti kalau ada pertanyaan bisa menyusul ya, ditanyakan ya terkait mungkin kebutuhan-kebutuhan mendatang ya. Silakan ya diskusikan dengan kami. Ya kami nanti akan coba mengakomodir pertanyaan-pertanyaan dari Bapak Ibu ya. Siapa tahu nanti emang akan ada kebutuhan.
Mm,
Mungkin gitu saja dari kami, Bu Cindy.
ya.
Pak Supra.
Oke,
Kita,
paling mungkin satu hal lagi ya Pak. Kalau misalnya Bapak Ibu ada yang mau coba trialnya, nanti boleh kontak ke Konstruk ya Pak Aldrin ya.
iya,
Nanti
iya,
kita
betul,
provide untuk trial atau evaluation
betul,
license-nya.
betul. Jadi
Oke.
emang kita kan agendanya itu adalah webinar workshop ya, Bu Cindy ya.
Mm-mm.
Jadi kita berharap dari webinar ini kalau ada kemungkinan kita akan buat workshopnya ke depannya. Dengan harapan Bapak Ibu paham dulu ya menggunakannya ya. Jadi kalau sudah paham berarti kan sudah ada gambaran ya ingin menggunakan software ini. Jadi semoga ya ke depan nih kita akan buat event workshopnya Bu Cindy ya.
Mm-mm. Mm-mm.
Yang tadi Bu Cindy sampaikan nanti kalau aku ada mungkin ada kebutuhan mencoba software trial ya nanti bisa kirim email atau WA ke saya ke kami di grup kita nanti kita akan propose ke Bentley ya Bu Cindy ya.
Mm-mm.
Ya,
Betul Pak.
ini gitu saja sih dari kami semua Bapak Ibu. Lagi mungkin disampaikan mungkin dari Miss Suarap ada lagi yang mau disampaikan?
Saurabh, maybe you want to add something before we close our webinar today?
Not as such. I already covered so many things. So
All good, right?
yes, yes.
Yes. Oke.
Okay.
Makasih Bapak Ibu semua. Thank you Mr. Sarap, Ibu Cindy. Sampai ketemu lagi di sesi berikutnya. Kita tutup Bu Cindy ya.
Ya, baik
Ya,
Pak.
selamat sore semua. Assalamualaikum warahmatullahi wabarakatuh. Sampai
Oke.
ketemu lagi Bapak Ibu semua. Terima
Ya.
kasih.
Selamat sore Bapak Ibu semua. Terima kasih untuk waktunya sore hari ini.
Sama-sama.
Thank you
Makasih
Saurabh.
Bu Cindy.
Ya, thank you Pak
Yeah,
Aldrin.
Ya,
Thank you
makasih
Bapak.
Miss
thank you.
Suara.
Bye bye.
Thank you very
Thank
much.
you. Thank
Thank
you.
you.
Bye.
Bye-bye. Di close ya, biar closing Bu.
Oke Pak.